Hey guys, welcome back to this particular series. In last video, we completed most of the questions, but few were left. So in this particular video, we will be focusing on those particular questions and make sure that you practice along so that you get a good idea. So let's begin. First question that we are going to see is question number 14. And in this particular question, you are given a perceptron model. So you have been given your sample data X and your labels Y, and you have this perceptron where tolerance is set to none and suffer is equal to false. So these are very good for us, and it is asking if we predict after fitting 1 1 what will be the output. So if you see here in your data itself 1 1 is there, right? So if it is there, then what will be the label? It will be 1. So that's why it's 1. Okay. Alternatively, you can plot this and check. So if it is 0 0, so that means here, 0 1, that means here, then 1 0 here, and 1 1 here. And if you see, there is a perceptron boundary here like this, right? Because this will separate us to 1 and these all things are separated at 0. The whole point of perceptron is to linearly separate our points such that they have the majority in that particular respective class. Okay, so that's the base idea of perceptron here. Now let's move on to the next question. So the next question is question number 29, and this is an ambiguous question because it says that latitude and longitude coordinates for each location. Which linkage method would be appropriate for this scenario? And first you need to understand what are complete linkage, single linkage, average linkage, and word linkage. So complete linkage is if you have two clusters and there are data points, then the data points between intercluster, that means cluster of one point pointing to cluster of another point, has the highest distance. If that is the case, then it's a complete linkage. In single linkage, it's just opposite. This should be having the lowest distance, so lowest. Now average linkage is if you have data points in one cluster and you have multiple data points in another cluster, or there are multiple data points in both cluster. What you do, you try to map each one, calculate the distance based on whatever metric it is given, and once you have done that, you will take consolidated value and then calculate the minimum of the average of things. So that's the base idea here. So average is there and word is similar to average but little bit different. So you have to read the documentation. We will look into that just a few seconds later. But as per question, it says that if you have to group similar location together based on their distances, where distance is given by latitude and longitude coordinate of each point, which linkage would be appropriate for this scenario? So it is not at all clear what will be the actual answer, but notice that it will be marked as complete linkage, and I think one reason behind it is that if you want that your clusters are different, then you should have the maximum distance between them so that it shows separation. But in terms of similar locations together, single linkage seems more appropriate, right? So there is an ambiguity. Now let's look at what are complete word, single, and average linkage. So let me just write the simple thing. What is complete word, single, and average linkage means in clustering. Okay. So complete linkage, also known as maximum linkage, distance between two clusters is defined. And the maximum distance between any single data point in the first cluster and single data point in the second cluster, the method tend to produce more compact clusters. Okay. So this was what I was also saying. Now for word linkage, it minimizes the variance within each cluster. At each step, it merges the pair of cluster that leads to minimum increase with total within cluster variance. So what it does is very simple, I guess. If you have clusters here in this and then you have clusters here, so what it does, it takes a pair, okay, and if the inter distance, that is the inside distance or the inertia that we call, is similar, then it tries to group it and then it tries to increase that, and then finally a final cluster will be formed, and this is called bottom to top. So method is effective for noisy data and tends to create cluster of similar size. Now single linkage, also known as minimum linkage or the nearest point algorithm. Distance between two clusters is defined as the minimum distance between any single data point in the first cluster and any single data point in the second. Method can handle non-cobbler clusters but sensitive to noise and outliers. So that's what I showed you between the single linkage also, and here is a detailed one. Now average linkage, also known as UPGMA, unweighted pair group method with arithmetic mean. The distance between two clusters is defined as the average distance between all the pairs of data points, one from each cluster. The method balances the compactness of complete linkage and chaining the effect of single linkage. So in general, we use average linkage in normal scenarios, but depending on the scenarios, you can change it. So that's the base idea. You can also refer to the scikit-learn documentation that is given here, and it will give you a complete idea of that. So I highly recommend that you check it out. Okay. So this marks the completion of our question number 29. Now on the similar lines, question number 30 is there. Let's look at that. Question number 30 says you are analyzing a data set transaction history. Each transaction includes purchase amount, time stamp. You want to identify group of customers based on their spending behavior. Which clustering approach would be appropriate for this scenario? So you are trying to identify the groups, right? And when there are groups, that means that there is a distribution. And if there is a distribution, the distribution based clustering can work. But there is one theory also. So the theory is that distribution based clustering mostly works on distance. It doesn't take account anything other. So if you have a group, that means that distance are far apart, or if they are very close, then inter distance will be very similar, right, between the clusters. But density clustering, what it does, it doesn't only takes distance, it also sees the compactness. And in such case, if you have points here and here, so in distribution it will create similar different clusters, but in density it might try to combine them, and that's what we don't want here, right? We want groups. So that's why distribution based clustering seems more optimal here. So that's thing keep in mind. Just understand what distribution and density based clustering is. Just to give you an idea, I will just try to explain it. So density and distribution based clustering difference. Let's check. So density groups together points that are closely packed together with many nearby neighbors and mark points that lie alone in the low density region as outliers, as I explained earlier. An algorithm that can do this is dbScan, density based spatial clustering of application with noise. So it handles noise. Okay. It can find arbitrary shaped clusters in robust to noise outliers, but it requires careful tuning of parameters like neighborhood radius, that is epsilon, how many neighbors should be there in the radius of that particular cluster, and the minimum number of points required to form the dense region. Okay. On the other hand, the simpler approach is density based. It assumes the data is generated from a mixture of several probability distribution, and each cluster corresponds to different distribution. So as I explained here, right, these two clusters, same thing. Okay. Gaussian mixture model, that is GMM, is common distribution based clustering algorithm. Also model clusters with different shape and sizes to provide a probabilistic framework for clustering. So it can model clusters of different shapes and sizes. Assume that data follows a specific distribution. This is one of the disadvantages of distribution based. It always assumes that your data has some type of distribution, mostly Gaussian, which is the most standard one in statistics, but that's the base idea here. Okay. I hope that you understood. The point of doing this is that so that you learn more things about that. Okay. So I hope that you will explore more, but this is the base idea. Okay. Now moving back to our calculative based questions. Okay. Now moving to our question number 4. In this question, you have been given this particular code and you also have been given this shape. And if you see, this is basically a code for transformation of our features, and it asks what is the shape of X transform. So in code, it will be very simple and you can directly do it. But if you don't have code, then how to solve this? So here some mathematics will be involved, and also theory you should know about feature union, how it works and how pipeline works. Okay. So 3 things I need to clear first. First is pipeline, second is column transformer, and final is feature union. So pipeline works sequentially, means as you put data, it will work that way, right? This feature is there, then scalar is there, right? So first feature, combined features will be taken, then scaling will be done. Okay. Now column transformer works on a specific column. On the other hand, feature union has all the columns taken because it doesn't specify extra array where it will say what is the index of that column, right? So that thing you need to take care. Now based on this, we will solve this, and obviously there are many ways you can do permutation, combination and everything, but there is a formula for this and you need to remember this formula in order to solve any type of question. And this formula makes sense also, though I am not going to explain you why it is making sense, but this is the formula. If you have interaction only is false, that means power terms are allowed, and bias is true, that means intercept is allowed, then you have this formula: n plus d, choose d, where n is total number of original features, d is your degree. So that is the thing for this first case. If there is a second case where interaction only is true, that means no power terms allowed, only multiplication term allowed. Okay. And your bias is again true, that means intercept is true. Then do n plus d minus 1, choose d minus 1. Okay, this you have to follow. So let's see what our cases are. Degree is 2. Okay, so d is 2. N is 8 by default. Okay, now include bias is false. So that means we will reduce one term from it. So if you see this way, then you will have 8 plus 2, that is n plus t, c 2. Okay, and after that you will subtract 1. So let's first calculate this. So 10c2. So that will come something around 45. And now you have this n component. So this PCA will also create some features, right? So that will be plus 5. So that will be 50. And now you have this include bias term as false. So that means you have to remove one term from it, right? So minus one term if we do, we will get 49. So here things will get complicated because here you have feature union, right? So polynomial transformation and PCA transformation, both we have to apply. That's why we are adding 5 to it. Else you will not do if it is a column transform. So keep that in mind. You can see that it's 49, right? So this marks the completion of our question number 4. Now let's move on to our next question. Now the last question that we are going to see is question number 10. You are given an equation. You are also given a value of W2 and the error or eta is 0. Okay, and you have to find the value of W. Okay, your x1 and x2 are the columns 1 and columns 2 respectively of W1 and W2 are the weights associated to respective column while fitting. So here your x train is there and y train is there. So let me just zoom it a little bit. Now you can see it clearly. Okay, so it is fitting a linear regression model and your intercept is false. So that means your intercept becomes 0. Okay, you have this x train, y train and regression coefficient of 0. So this 0 basically represents W1. Based on this equation, let's try to understand. So this equation is actually your y truth, that is your actual labels. Okay, but what we want is y pred, because when you have your linear regression line and your data points like something like this, and obviously it makes sense here, so your actual y pred is this, right, these points. So your error rate becomes 0 in this particular, as they are all lied on the line W transpose. Obviously it is a difference, so this difference you have to calculate, that is y pred minus y truth, but that's not of concern here. We mainly focus on how to find this W1. Okay, so let's try to do that. Okay? What we will do is we will set y is equal to y. Okay, now W0 x0 will become 0. Why? Because W0 is the weight associated with x0 and it is simply said that our intercept is 0. So W0 will represent the weight of the x0. x0 is what? It is the intercept value, but intercept is becoming 0. So W0 times 0 will become 0. Now W1 is not given to us, but x1 is given to us. Okay, so we will keep that x1 here only, no worries with that. And then we have W2 and we have been given that W2 is 5 by 7 times W1, right? So 5 by 7 times W1 times x2. x2 is also given it, but for now we will do it right. And error is also given to us as 0, right? So 0 we will put here. Now this term becomes 0. This we can take W1 common from it, right? So W1 we take common. So x1 plus 5 by 7 of x2. And error is 0, so we will not worry about that. Now 0 plus W1 is not given to us. This 0, 0 we will ignore because that will make no sense here. We will put x1 as 2 and x2 as 1.43. So 2 plus 5 by 7 into 1.4, right? So till here we will get some W1 times some value. Now what is the label of this? It is 1 and we are actually focusing on y, right? So 1 is equal to W times, say this is some z. So 1 by z is equal to, obviously I am not solving it, but mostly if you solve you will get something similar on this lines. So keep that in mind. This is for you to practice. Okay, so with this we have completed our entire question paper and I hope that you understood a things or two, and make sure that you please practice this. If you are liking this video, please share it with others. It will help others also. If you are having some doubts, please answer me in comments and I will see you in next video. Till then, bye bye.